There are lots of things moving throughout our world daily. People are moving by planes and other modes of transportation. Goods are being moved on ships. And wildlife is regularly moving. This movement is both legal and sometimes illegal in the case of trafficking of illegal goods or people. Much research has been successful in utilizing movement data to understand phenomena for urban planning, disease spread, and wildlife migrations, just to name a few. The vast majority of this research relies on data that comes in the form of trajectories recorded with precise spatial and temporal sensors like GPS. However, much of the world's information comes in the form of text, like news articles, social media, and science articles. Our research focuses on techniques to make this underused form of movement information more accessible. As an example to show motivation for our research, this statement clearly illustrates there is a storm over the location Avalon, the person is nearby watching the storm, and then they travel via automobile along the freeway and stop in the area of Orimba to view more storms. And perhaps most importantly, the statement makes clear the reason the person is moving, to watch and photograph these strong storms. In addition to this contextual information, there is potentially valuable linguistic information like the author's tone, sentiment, and enthusiasm, a time reference, details about the storm's nature itself, and the author's reasoning behind her or his movements and stops. Given this information, it would be straightforward to map this movement like what is shown in the right with storms near Avalon Beach, Australia in the south, the person's driving route along the M1 freeway north, and more storms near Orimba to the north. Movement statements have the advantage over trajectories of rich contextual information about why the movement is occurring. Therefore, geographic movement described in text documents can complement detailed movement data, provide an alternative when precise data does not exist, and provide the added benefit of rich context about the movement. To fill this gap in research, as an initial large-scale effort to derive meaningful information from textual data describing geographic movement, we applied multiple computational techniques to hundreds of millions of statements from 3 sources of text documents. First, we predict those that describe geographic movement using our previously developed machine learning-based methods. Second, we identify and geolocate the geographic places mentioned using geographic information retrieval geographic feature extraction techniques. Third, because the current coronavirus pandemic highlighted the importance of global movement disruptions, we implemented a novel adaptation of negation detection in text to predict if the statement describes impaired, restricted, or canceled movement. Since the data is messy and complicated, and the prediction techniques are not perfect, we created the GeoMovement Geovisual analytics system that provides a visual interface to enable humans to explore initial statement classifications, the places mentioned in them, and co-occurring place mentions. This assesses the validity of computational methods and can provide direct feedback towards improving results. The GeoMovement application design matches Dr. Ben Schneiderman's information-seeking mantra of overview first to gain awareness of the information, and then details of interest on demand. Overviews include a map that shows the over 90,000 unique place mentions in our dataset with their respective statement counts aggregated to multiple geographic bin scales. This is because we found in our previous research that the geographic scale of the movement is important to people in differentiating it. The user can choose from 5 different classification methods for the resulting aggregate counts of statements with locations in each bin. Time is aggregated by month with the diverging bar chart where the left side purple bars are the number of negated movement statements and the right green bars are normal movement. And the final overview is a list of the most common bigrams for the statements. Overviews update as searches are performed based on the matching statements. A free text search, the text source search, a time range search, and our negated versus normal movement search are provided. The search options enable users to forage for locations, times, and statements that require detailed reading. When clicking on a location in the map of interest, detailed views show the connections between that location and co-occurring places in the statements, and the actual statements that match the searches. A control click on a statement will open a new web browser window and navigate to the statement's source document on the web. Out of the approximate 520 million statements in the GeoMovement system, 36,000 contain the word smuggling, 275,000 contain gold, 336,000 contain sports, 589,000 contain London, 165,000 contain California, and 201,000 contain India. These large values show that even though we have a small fraction of text documents, without our GeoMovement geovisual analytics system making sense and deriving meaning from statements that describe movement, even on individual topics and places, would be challenging, if not unfeasible. Our real-time case study follows Yusuf, who is an amateur political scientist interested in the responses to the pandemic of the Gulf Cooperation Council countries. First, he moves the time range filter to select only February 2020. Next, he selects Twitter to see some discussions outside mainstream media. To better see differences in amounts of discussion, he switches the map classification to quantiles with 7 classes. Kuwait shows worries about coronavirus related to Iran and Bahrain, and there are discussions of a travel ban. Bahrain has similar worries. Viewing statement shows Kuwait, Bahrain, Oman, and UAE are taking similar responsive measures. Qatar is also concerned about Iran and is evacuating their citizens from there. After choosing to show only impaired movement, UAE is taking many steps to cancel travel and events and is also concerned about a migrant worker who died from the coronavirus. From clicking on Oman, he sees a strong connection with Iran and now with China because they have barred entry from these countries. Saudi Arabia is in discussions about canceling the annual Muslim pilgrimage to Islam's holiest city of Mecca, where people come from around the world to perform Hajj. Switching to hexagon bins shows greater detail, and again clicking on Kuwait shows a link with a location inside Iran. This location contains the city of Qom, where Shia Muslims recently returned from, carrying coronavirus with them. Yusuf now has a summary and many details about common concerns among GCC countries as well as those specific to each. The GeoMovement system utilizes Elasticsearch to provide extremely fast search responses to the user, thereby easing their sense-making process, as seen in our unedited real-time case study demonstration. Elasticsearch easily scales to much larger sets of documents and near real-time streaming of documents while maintaining search speeds by adding additional computer nodes. To advance the system's effectiveness, future editions will incorporate streaming sources of text and take advantage of user interactions that can improve the machine learning model's predictions accuracies. Future research should take advantage of the wealth of context information found alongside geographic movement in text documents about why, when, and how the movement is occurring that is not often present in precise GPS trajectories. We anticipate that others can build upon our initial efforts to analyze the geographic movement described in text documents to improve analysis with this information. The GeoMovement application was conceived and developed by Dr. Scott Pesanowski in collaboration with Dr. Alan McEachran and Dr. Prasenjit Mitra, all of whom are affiliated with the Pennsylvania State University.